Creating and using offers is a core concept in Agoric that enables secure and flexible interactions within smart contracts. In this section, we will explore the process of creating offers, ensuring offer safety, and handling offers within contracts. Let's break down these key components. Offer safety is a critical concept that ensures participants in a contract can safely make offers without the risk of losing their assets unfairly. Offer safety ensures that users either get what they want or get their assets back. This guarantees that participants are not worse off after making an offer. Zoe, the Agoric contract framework, enforces offer safety by managing offers and ensuring that the terms are met or assets are returned. An offer in Agoric consists of several components, including the offer hook, proposal, and payments. The offer hook is a callback function that processes the offer. A proposal specifies what the user wants to give and receive in the offer. And payments are the actual assets being offered. Creating and submitting offers involves several steps. First, you must create the invitation. Use Zoe to create an invitation to interact with the contract. Next, you'll submit the offer. Use the invitation, proposal, and payments to make an offer. Next, handling the offer. The contract processes the offer using the offer hook and responds accordingly. Some elements in Agoric, like contracts and purses, are designed to persist over time and maintain state. These objects, such as contracts and invitations, can be reused and interacted with across multiple transactions. Use contracts to manage long-term state and ensure that offers and assets are handled correctly over time. Understanding how to create and use offers is essential for developing robust smart contracts in Agoric. By mastering these concepts, you can build contracts that handle transactions securely and efficiently, ensuring that all participants are protected and that assets are managed correctly. Next, we'll dive deeper into the concept of offer safety and explore how Zoe ensures that offers are handled securely and fairly. Offer safety is a fundamental principle in Agoric smart contract framework that ensures fairness and security in transactions. Let's delve into what offer safety means, its importance, and how Zoe, Agoric's contract framework, enforces it. Offer safety guarantees that participants in a contract will not lose their assets unfairly. It ensures that users either get what they agreed upon or get their assets back. Users will not be worse off after making an offer. They will either receive the desired outcome or get their original assets back, guaranteeing no loss. This concept protects users from malicious or faulty contracts, providing a secure environment for transactions as well. Offer safety is crucial for maintaining trust and security in decentralized applications. It ensures trust. Users can trust that their assets are protected and that they will not be cheated by the contract. Offer safety ensures reliability. Contracts behave predictably and securely, making decentralized finance and other applications viable and safe. And finally, offer safety ensures user protection. Offer safety ensures that all participants are treated fairly and that their assets are safeguarded. ZOE is the contract framework in Agoric that enforces offer safety. ZOE manages offers and ensures that the terms of the contract are met or assets are returned to the user. ZOE handles the life cycle of offers, ensuring that they are processed securely. ZOE checks that the conditions of the offer are met before completing the transaction. And if an offer cannot be fulfilled, ZOE ensures that the user's assets are returned. Offer safety, enforced by ZOE, ensures that smart contracts on the Agoric platform are secure, fair, and reliable. By adhering to the principles of offer safety, you can build contracts that protect users and provide a trustworthy environment for decentralized applications. Next, we'll look at the anatomy of an offer, breaking down its components and how they work together to facilitate secure transactions in Agoric. Understanding the anatomy of an offer is crucial for working with smart contracts in Agoric. An offer consists of several components that work together to facilitate secure and efficient transactions. Let's break down these components. The offer hook is a callback function that processes the offer. It's responsible for handling the logic of what happens when an offer is made. The offer hook is defined when creating an invitation. It creates the code that will execute when an offer is accepted. This function can include logic for accepting, rejecting, or modifying the offer based on the contract's terms and conditions. The proposal specifies what the user wants to give and receive in the offer. It includes three different parts: give, want, and exit. Give are the assets that the user is offering. Want represents the assets that the user expects to receive. An exit contains the conditions under which the user wants to exit the offer. Some examples include on demand and after deadline. Payments are the actual assets being offered in the transaction. They are spendable representations of the digital assets specified in the give part of the proposal. Payments are created by withdrawing from purses or during the minting process. These payments are submitted along with the proposal when making an offer. By understanding these concepts, the offer hook, proposal, and payments, you can create offers that are secure and adhere to the terms defined in the contract. This structure ensures that all participants in the contract understand what is being exchanged and the conditions of the transaction. In this example, we define a hook to handle the offer. We create a proposal specifying the terms of the offer, and we create payments representing the assets being offered. We then create an invitation and submit the offer using the ZOE framework. Take a moment or two to review this full example. When you're ready to continue, we will go through the step-by-step process of making an offer, from creating the invitation to handling the result. Making an offer in Agoric involves several steps that ensure the transaction is secure and adheres to the contract's terms. Let's walk through the process step by step, from creating the invitation to handling the result. Making an offer involves a series of coordinated steps, beginning with creating the invitation. The first step is to create an invitation that will allow participants to make offers. The invitation is generated using Zoe and includes the logic for handling the offer. Next, we'll define the proposal. The proposal specifies the terms of the offer, including what the user is giving and what they want in return. It also includes exit conditions. Next, we'll prepare the payments. Payments represent the actual assets being offered. They're created from purses or through minting. Then we'll submit the offer. The offer, including the invitation, proposal, and payments, is submitted to Zoe for processing. And finally, we'll handle the result. After submitting the offer, the result is handled to determine if the offer was accepted, rejected, or if additional actions are needed. Submitting an offer to Zoe involves packaging the invitation, proposal, and payments together and sending them to the contract. Use Zoe's offer method to submit the offer, which returns a user seat. This seat allows the user to interact with the offer and retrieve the result. The response from the contract, such as offer acceptance or rejection, can be retrieved through the user seat. Let's look at a practical example that demonstrates the entire process of making an offer, from creating the invitation to handling the result. We'll begin by creating an invitation using Zoe. Then we'll define the proposal with the terms of the offer. In step 3, we'll prepare the payments for the assets being offered. And in step 4, we'll submit the offer and handle the result. Here you can see these 4 steps in action. By following these steps, you can make offers in Agoric smart contracts that are secure and compliant with the contract's terms. This practical approach ensures that transactions are handled efficiently and that participants are protected. Take a moment to review this full example code. When you're ready to continue, we'll move on by discussing how to handle offers in smart contracts, including offer acceptance and rejection, to ensure that your contract processes offers correctly. Handling offers in smart contracts is a critical aspect of ensuring that transactions are processed correctly and securely. This involves writing contract code that can accept or reject offers based on predefined conditions. Let's explore how to handle offers within Agoric smart contracts. When an offer meets the conditions defined by the contract, it is accepted. This involves executing the logic specified in the offer hook and updating the contract state accordingly. Begin by checking conditions. Ensure the offer meets all the required conditions before accepting it. Then execute your logic. Perform the necessary actions to complete the offer, such as transferring assets or updating records. And finally, exit the seat. Mark the offer as accepted and exit the seat, which finalizes the transaction. If an offer does not meet the contract's conditions, it is rejected. This ensures that only valid and acceptable offers are processed. Begin by checking conditions. Evaluate whether the offer meets the required conditions. If it does not, reject the offer. The offer is rejected by exiting the seat without performing any transactions. And finally, return assets. Ensure that any assets involved in the rejected offer are returned to the user. Writing contract code to handle offers involves setting up the offer hook, defining the proposal, and processing the offer based on the conditions. Create a function that processes the offer, checking conditions and executing logic for acceptance or rejection. Define the terms of the offer, specifying what is being given and what is being received. Use the offer hook to handle the offer, ensuring that it is either accepted or rejected based on the conditions. In this example, the offer hook checks whether the offer can be fulfilled based on the conditions defined in the proposal. If the conditions are met, the offer is accepted. Otherwise, it is rejected. This ensures that only valid offers are processed, maintaining the integrity and security of the contract. Handling offers correctly is crucial for building robust and secure smart contracts. By following these practices, you can ensure that your contracts process transactions efficiently and fairly. Take a moment to review this full example code. When you're ready to continue, we will move on by discussing long-lived elements in Agoric, which help manage persistent state and reusable components in your contracts. Long-lived elements in Agoric smart contracts are crucial for managing state and creating reusable components. These elements persist over time, allowing contracts to maintain continuity and provide stable services. Let's explore the key aspects of long-lived elements in Agoric. Persistent objects are those that retain their state over the lifetime of the contract and across multiple interactions. These objects are foundational for building long-term complex functionalities within a contract. Some examples of common persistent objects include purses, vaults, and smart contract instances. Hardened state is important as well. To ensure security, persistent objects should be hardened, making them immutable and resistant to tampering. Managing state effectively in a smart contract is crucial for ensuring that the contract behaves consistently and securely over time. Use contracts to manage the state, ensuring that all changes are intentional and tracked. Handle state updates in a controlled manner, using methods that validate and enforce the contract's rules. Implementing best practices for managing long-lived elements ensures that your contracts are robust, secure, and maintainable. Always use harden to freeze objects that should not change, ensuring their immutability and security. Design your contracts in a modular fashion, separating concerns and making it easier to manage and update state. Finally, use consistent and well-documented interfaces for interacting with persistent objects, making it easier for other developers to understand and use your contracts. By using long-lived elements effectively, you can build Agoric smart contracts that are not only powerful, but also maintain a consistent state over time. This approach helps in creating reusable components and managing state efficiently, ensuring that your contracts can handle complex interactions and maintain their integrity. Next, we'll wrap up this section with the conclusion. Let's briefly recap the key points that we've covered in this module. We discussed the best practices for writing secure and efficient smart contract code. We explored the essential functions E and harden, which are critical for ensuring security and immutability in your contracts. Using the DAP OfferUp tutorial, we learned about the structure and components of an Agoric smart contract. We walked through the steps of building, deploying, and interacting with the simple contract on the Agoric platform. We examined the roles of brands, issuers, and mints in creating and managing digital assets. We explored how to create, transfer, and securely manage digital assets using purses, payments, and amount math. We delved into the concept of offer safety and how Zoe ensures secure and fair transactions. We broke down the anatomy of an offer and demonstrated how to create, submit, and handle offers in smart contracts. We discussed how to accept or reject offers based on predefined conditions and provided examples of contract code to handle these operations. We covered how to manage persistent objects and state in your contracts, and we highlighted best practices for ensuring that your contracts are robust, secure, and maintainable over time. By mastering these concepts, you are well equipped to develop secure and efficient smart contracts on the Agoric platform. I encourage you to apply these principles and continue exploring the capabilities of Agoric. In the next module, we'll be diving into the components you'll be using to build your own DAP on Agoric.